Alright, ladies and gents, throughout the chapter we've been talking about these polynomial functions, so I figure it's a good idea to get an idea of what these graphs are going to look like. So, these are basically the 5 most common types of graphs. Our first is going to be a constant function, so that's a function, say, for example, if it's y equals 3. So y equals just some number. It's going to be a flat line where at whatever this value is. So if y is equal to 3, we're going to go up to 3 and go to a straight line. This linear function, that's going to be y equals mx plus b. M being the slope, b being the y-intercept. So this point right here is going to be 0, comma b. This third graph, the quadratic, that's going to be the form of y equals ax squared plus bx plus c. And this is just going to get bigger and bigger. So a cubic function, our highest exponent is going to be 3, and it's going to reduce all the way until a constant. A quartic is going to be a degree 4, and it's going to go all the way down to a constant again. And a quintic, that's going to be a degree 5. So our highest exponent is going to be 5. Now I want you to take notice. Take a look at these trends. Our odd degrees, 1, 3, and 5, they're both going up to the right and down on the left. Up on the right, down on the left. Up on the right, down on the left. And our even degrees are symmetric. So they're either both going down or they're both going up. Alright, now that last trend I'm going to further explain right now. First, I want to recognize that this side is even degree polynomials. So we're talking about squared, quartics, to the 6th power, to the 8th power, and so on and so forth. And on the right side here, we're talking about odd degrees, so linear, cubics, to the 5th powers, 7th powers, and so on and so forth. On the top, it's going to be positive leading coefficients. That means the number way out front is going to be positive. And down here, negative leading coefficients. It means the number way out front is going to be a negative number. So we're going to talk about end behavior. End behavior is just describing what's happening at the ends here. So for our even degree with a positive leading coefficient, for example, y equals x squared, as on the left side, that's going to be as x approaches negative infinity. So on the left side, what's happening to our y? Well, on the left, as x approaches negative infinity, our y is going up. So that means our y is approaching infinity. As x approaches positive infinity, that's the right side. As x approaches positive infinity, our y is approaching also infinity. Okay, so those even degrees, they're symmetric. They're going to be the same thing on both sides. Now for the odd degree. As x approaches negative infinity on the left side, what's happening to my y? As x approaches negative infinity, my y is going down. That means as x approaches negative infinity, y is going to approach negative infinity. As x approaches positive infinity, what's happening to my y? So we're looking at our right side. X approaches positive infinity. What's happening to my y? It's going upwards. So that means y is going to approach positive infinity. And negative leading coefficients. So we got an even function here. It means it's symmetric on both sides. As x approaches negative infinity, that's this side, my y is going downward. That means y is approaching negative infinity. And since it's an even function, it's going to be symmetric on both sides. Now looking at the other guy. As x approaches negative infinity, what's happening to my y? It's going upward. So that's approaching positive infinity. And as x approaches infinity, that's this side right here, as x gets bigger and bigger, my y is going down. That means it's approaching negative infinity. Alright, so this is what you want to pay attention to. These little boxes here. So when I say to describe the end behavior, this is what I'm referring to. You'll have to tell me what's happening to the x's and the y's on the ends, and if they're positive or negative. Alright, for these problems, I said to determine if it's even or odd, and then describe the end behavior. So, we got, alright, let's look at this first one on the top left. Describe if it's even or odd. So if it's even, it's going to be going the same direction on both sides, and if it's odd, they're going opposite. But you can see that these are both going down. That means it is even. Now I want to describe the end behavior. So as x approaches negative infinity, that's this side right here, what's happening to my y? Y is approaching, is it going up or down? It's going down. So y is also approaching negative infinity. And as x approaches positive infinity, that's on the right side. So what's happening to my y? It's going down as well. So y is approaching negative infinity. Look at the second one to the right. Is it even or odd? Okay, this one is going to be odd because they're going opposite directions of each other. As x approaches negative infinity, that's on the left side. Y is approaching positive infinity. As x approaches positive infinity, that's on the right side. So what's happening to my y? The y is going down, so it's going to be approaching negative infinity. Alright, for homework I want you to tell me the even or odd, or describe the end behavior for both these graphs down here. It shouldn't be too bad. See if they're symmetric on both sides. See which side's going up and which side's going down.